Assalamu alaikum student. Today we discuss the topic that is the what is an RL series AC circuit. In RL series AC circuits, we take the resistor R, inductor L and capacitor C in series, apply the alternating voltage. So here we represent the alternating voltage V, resistor R, inductor L, capacitor C. When we apply the voltage across the resistor, inductor and capacitor, current I is flow through these circuit element. So here we write about the an RL series circuit consists of a resistor R, inductor L and a capacitor C. Current flow through each component. An RL series AC circuit consisting of a resistor R, inductor L. Inductor is that is the always shows by the L and a capacitor C. When we connect the RL series component in series and apply the voltage V, then the same current is flow through each component. So here we write that same current flow through each component. Next we discuss about the RL series AC circuit voltage. Okay, now here we discuss that the voltage. Okay, first understand that the voltage is divided across these components because it is connected in series. Voltage across the resistor that is represented by VR and voltage across the inductor that is represented by VL and voltage across the capacitor that is represented by VC. So here we again draw the diagram that we take the resistor R, inductor L and capacitor C that is connected in series and apply the alternating voltage V. When we connected the alternating voltage V across the resistor R, inductor L, capacitor C and current I is flowing through each component that is same, but the voltage across the each component is divided. Voltage across the resistor R is represented by VR. Voltage across the inductor L is represented by VL and voltage across the capacitor is represented by VC. So here we write that in this circuit, the current flow through each component. The current flow through each component is same but voltage is divided. Voltage across the resistor is represented by VR and VR that is equal to IR. Voltage across resistor, voltage across resistor that is represented by VR that is equal to IR according to Ohm law. Then the voltage across the inductor, voltage across inductor that is represented by VL, VL that is equal to IXL. In the inductor, we show the resistance by inductive reactance that is equal to V is equal to I omega L. Similarly, we represent the voltage across the capacitor, voltage across capacitor that is represented by VC, VC that is equal to IXC, and XC that is represent the inductive reactance, show the opposition to the flow of the current, and IXC that is equal to 1 over omega C, that is the current, and XC that is formula is equal to 1 over omega C. Okay, next we discuss the phasor diagram. What is the phasor diagram? In the phasor diagram, first we draw the diagram, that is we take the resistor R, inductor L and capacitor C is in series and apply the alternating voltage V across it. So here we apply the take the resistor R, inductor L and capacitor C is connected in series and apply the alternating voltage V across it. Resistor R, inductor L and capacitor C, and we know that the voltage across the resistor, inductor and capacitor is divided. So here the resistor and the voltage is VR, voltage across the inductor that is the VL, and voltage across the capacitor that is the VC. Then the same current flow through each component. Okay, now we draw the phasor diagram and we know that the current through each component is same. So we take the current as a reference axis. Here we take the current, that we take the current as a reference axis. Okay हो गया. अच्छा. Next we discuss that the voltage across the resistor and the current both are in same phase when they passing through the resistor R. They we discussed in the last lecture, whenever the current is passes through the resistor R, then the voltage VR and current both are in phase, in the same phase. So here we draw the voltage across the resistor R that is in phase with the current. So both the directions are same. So VR and I, both the directions are same. So when the current is passes through the inductor L, we know that the inductor is always oppose the change of current. So current is always lag behind the inductor L by voltage VL. Always lag behind the voltage VL by 90 degree. So Here we write that the voltage always lead in the inductor L by the current by 90 degree. So here we write the V L. When the current is passes through the capacitor C, in the capacitor current is always lead the voltage V C by 90 degree. So here is the voltage is lag but current is lead. So here is the diagram of the voltage, phasor diagram of the voltage VC, that is the lag behind the current by 90 degree. So this is the phasor diagram of the VC. Now we draw the phasor diagram of the applied voltage V. Applied voltage V, that is make an angle phi with the reference axis current I. So here we take the applied voltage V, that is make an angle phi with the reference axis I. So what we discuss here, across the resistor R, across resistor R, in this case voltage and current are in phase. Voltage and current are in phase. Across the inductor L, across inductor L, voltage lead current by 90 degree. When we discuss about the capacitor C, that is voltage is lag the current by 90 degree. So here we write that the across the capacitor C, across capacitor C, voltage lag the current by 90 degree. Voltage lag current by 90 degree. That is all we discuss what is an RL series circuit. Then we discuss the RL series AC circuit voltage, and last we discuss the by the phasor diagram. Here we discuss about the when the voltage is in phase with the current and what is when the voltage is lag or lead the current. Whenever the current is passes through the resistor R, they both are in the same phase. When they passes through the inductor L, the voltage lead the current by 90 degree. When they passes through the capacitor, then the voltage lag the current by 90 degree. Okay. Next we discuss the resultant voltage. How we calculate the resultant voltage? Resultant voltage we can calculate by the phasor diagram when the voltage across the inductor L is greater than the voltage across the capacitor C. So here we discuss the resultant voltage. First we draw the phasor diagram. Here we draw the phasor diagram. We take the current has the reference axis. When the current is in the reference axis, the voltage VR, that is in phase with the current. And here we take the condition when the voltage across the inductor L is greater than the voltage across the capacitor C. In the last diagram, we discussed that the voltage always lag behind the current by 90 degree. When we draw it upper, so VL is minus VC, VL is greater than VC, and here we draw right at the VL minus VC, and here we take the current that is shows the resultant voltage V and make an angle phi with the reference axis I. So here we write that if VL is greater than VC, then the resultant voltage V is, how we calculate the resultant voltage V? When this parallel line show the VL minus VC, if we draw the perpendicular from the applied voltage V on the x-axis, reference axis I, so that is equal to VL minus VC. So we can calculate the resultant voltage V, that is equal to under root VR square plus VL minus VC का whole square. Okay, later we discuss that the VR that is equal to VR that is equal to IR whole square, VL that is equal to IXL minus VC that is equal to IXC whole square. So here we can write that I under root R square plus XL minus XC का whole square. That is, this factor shows the impedance of the circuit. So here we write that this is the shows the impedance. What is the impedance? That is the combined opposition offered to the flow of the current by the circuit. So here we write that this is shows the combined impedance. Impedance, that is formula that is equal to R square plus XL minus XC का whole square when it is connected in series is the combined opposition offered by circuit element is called impedance. That is shows by Z. Okay, next we discuss the phase angle. Okay, when we discuss the phase angle in RL series AC circuit, the voltage V lead the current by an angle phi. Again, we draw the same phasor diagram and then we calculate the phase angle. Here we discuss the resultant voltage and we calculate by the phasor diagram. Now we calculate the phase angle. Okay. First we draw the phasor diagram. Same diagram. In the x-axis we take the voltage VR and the y-axis we take the voltage that is VL minus VC and the resultant voltage V, and that is make an angle phi with the reference axis that is the current I. Okay. Here we take the voltage across the, find the angle tan phi. We know that the tan phi can be made by the perpendicular our base. Here is the perpendicular, that is the VL minus VC, and base, that is the VR. So here we write that the perpendicular VL minus VC and base, that is the VR. Okay, we know that according to the Ohm law, that is VL is equal to I X L, and VC, that is equal to I X C, and VR, that is equal to I R. Here we take the current is common. When the current is common, they cancel the effect of each other. So final equation become XL minus XC over R. So by this formula we can find the phase angle phi, that is equal to tan inverse XL minus XC over R. That is, we can find the phase angle by this formula. Now we discuss the three cases about this formula. Uh, discuss these three cases. First we discuss that if XL is greater than XC, whenever the inductive reactance is greater than the capacitive reactance, so circuit is inductive, current is lag. So here we write that circuit inductive or current lag. That is the first case. Second case, we discussed that when the capacitive reactance is greater than the inductive reactance, then the circuit is capacitive. Circuit capacitive and current is lead. And third case, we'll discuss that when the XL is equal to XC, then the phase angle is 0 because they cancel the effect of each other. So circuit behave like pure resistor. It constant of only resistor when the inductive reactance is equal to the capacitive reactance. So here we discuss about the phasor diagram, in which we first calculate the resultant voltage, then we discuss the impedance, how we calculate the impedance, that is the combined opposition offered by the resistor, inductor and capacitor is C. Then we find the phase angle. We can find the phase angle. We know that the tan phi, that is equal to perpendicular over base. Here we take the perpendicular, that is equal to VR minus VC, and the base, that is equal to VR. So put all the values here. So we have to find the phase angle. Then we discuss the three cases. First we discuss that when XL is greater than XC, then it is the circuit is inductive and current is lag. Second case, we discussed that the XC is greater than XL, so circuit is capacitive. When the circuit is capacitive, current is lead. And third is case, that is we discussed that when XL is equal to XC, so in this case circuit is behave like the pure resistor. So next we discuss the impedance triangle. How we draw the impedance triangle. In this phasor diagram, we now show the impedance. In the impedance triangle, we show the impedance, that is shows the combined effect of the RL series circuit. So here we draw the impedance triangle. Impedance triangle, we draw that we take the reference axis, we take the resistor R, and the perpendicular we take the inductive reactance XL minus XC, and here we shows the, इसको दूसरे मार्कर से शो करना था, impedance Z, and that is make an angle phi with the resistor R. So here shows the impedance triangle, here shows the impedance triangle when XL is greater than XC, when inductive reactance is greater than capacitive reactance. Okay, various impedance triangle here we discuss the case when XL is greater than XC. Here we discuss the impedance triangle when XC is greater than XL. So here we draw the phasor diagram. In the reference axis we take the resistor R. Here we take the reactance, that is the XC minus XL. Here we shows the resultant impedance, that is the combined opposition offered by both, that is make an angle phi with the impedance. So this is the impedance triangle. Impedance triangle when the case discussed that when the inductive reactance is greater than capacitive reactance. Then we discuss the impedance triangle when the capacitive reactance is greater than inductive reactance. So here we discuss the three cases. First we discuss the phasor diagram, then we discuss the phase angle, and third we discuss the impedance triangle. Okay, now we move to the next topic, that is the power in RL series AC circuit. Okay, now here we discuss the power in RL series AC circuit. Okay, we know that the average power is consumed by inductor and capacitor is 0, but AC power is always consumed by the resistor R. The both elements are not consume power, that is the inductor and capacitor. Resistor, that is the consume only power. So here we take the calculate the average power of RL series AC circuit. The average power dissipated in AC circuit of inductor, capacitor and resistor is connected in series, not only depend upon the value of the voltage and current, but also depend upon the phase difference between them. So here we write that not only depend on the root mean square value of current and voltage but also the phase difference phi between them. So factor cos phi, the factor cos phi is called the power factor. So here we shows the impedance triangle when the XL is greater than XC. It is make an angle phi with the reference axis R. Here we take the XL minus XC, and here we take the impedance of the resistor R, inductor L and capacitor C. So we can calculate the power factor cos phi by this impedance triangle. We know that the can find the cos phi base our hypotenuse. Here we take the base, that is the R, and hypotenuse, that is the Z. So in the base we take the R and hypotenuse, that is equal to Z, and we calculate that Z, that is equal to Z is equal to R square plus XL minus XC का whole square. That is, we calculate the power factor. Now we discuss the cases about these power factor. First case we discuss the when it is the purely resistive circuit and when it is the purely inductive and capacitive circuit. We can find by this formula. So next we move to the purely resistive circuit. Purely resistive circuit is when purely resistive circuit when XL is equal to X C cos phi, that is equal to R our under root R square plus XL minus XC whole square. So we know that when XL is equal to XC, so cos phi, that is equal to R our R, that is equal to 1. So we know that cos phi is equal to 1 when the angle is between them is 0 degree. So when the angle is 0 degree, when the voltage and current are in phase. When the voltage and current are in phase, so that circuit is called the purely resistive circuit. Now we discuss the purely inductive circuit. When the purely inductive circuit, we also calculate it by this formula, purely inductive and capacitive circuit. Okay, when the purely inductive and capacitive circuit, we know that the voltage and current, that is make an angle between them is phi is equal to 90 degree. That phase difference is 90 degree. When the phase difference is 90 degree, so power factor, that is become is equal to 0. In this case, that is called the purely inductive and capacitive circuit. So last we discuss about this, that is the, so capacitor So inductor and capacitor consume no power power only consume due to resistance only. So power in the RL series circuit is only consumed by resistor. Inductor and capacitor is consumed no power. So here is we discuss the power in RL series AC circuit. Hope you understand the today lecture that is about the RL series AC circuit. First we discuss what is an RL series AC circuit. Then we calculate its resultant voltage and phasor diagram. In the last second one, we discuss about the phase, angle, and then we will discuss about the three cases. In three cases, we discussed that when the inductive reactance is greater than the capacitive reactance, and capacitive reactance that is greater than the inductive reactance. And in the last lecture, we discuss about the power in RL series circuit. In this topic we discussed that the power is only consumed by the resistor, inductor and capacitor is consumed no power. Okay, here we end this lecture, and in next lecture we discuss about the LC oscillation circuit. What is the LC oscillation circuit? How the energy is transferred between the inductor and capacitor. In this lecture we discuss about the LC oscillation circuit.